Another question on Green's theorem. So far, we've in our previous example, we've implemented Green's theorem to different questions using different approach. We've done for a square bonded, we've done for a triangle, and we've done for curve. Right now, in this case, we are having circle. We are given an equation of a circle, so we are making use of this equation of a circle given. Alright, we said we have the normal approach and we have the parameterization formula. So in this case, related question like this, just that for every question, they have their own approach. So when you see a similar question like that, you are just going to implement the approach of what you've learnt in related question. So for question like this, you implement parameterization. Generally, just that for equation of a circle, okay, first thing first, let's write out our formula. I have integral Pdx plus Qdy is equals to double integral partial derivative of Q with respect to x minus partial derivative of P with respect to y multiplied by the A. This is R, this is C. So now, say you want to implement this line integral, which is integral C all into bracket P dx plus Q dy. You need the function of P, you need the function of P, you need the function of Q, you need the function of the x, and you need for what? Dy. Now, by the time we do comparison, just like what we explained previously, you can check our videos, you can check the previous videos on Green's theorem. Just like what we explained previously, by the time we do comparison to this given question, say this given question, x dx plus y dy is equivalent to your formula of line integral, meaning P dx plus Q dy. In this case, P is equal, this will cancel out, this cancel out, right? This also cancel out, this also cancel out. You are left with P is equals to x and Q is equals to y. So what you are saying is that P is equals to x and Q is equals to y. Now from here, in place of, so what this means is that using this formula, you substitute x and you substitute what? Y, which is the given question itself. So there's no stress on that, because from here you already have, given from the question itself, you already know P and Q. Alright. Now how do you get the x and the y? We said to get the x and the y, a function must have been differentiated. Now take note, for a circle, whenever you see Green's theorem having an equation of a circle, for your formula for parameterization is that for x, okay, before then, say you have x squared plus y squared equals to 1. From here, you can relate x as cos y, or you say sin y, and you can relate y as what? Sin x. The question is what? Go back to your trigonometry. From trigonometry, you have that cos square y plus sin square y is equals to what? 1. Right? You have this, meaning you can say that x is equals to cos 1, or you say x is equals to sin y. You see the same thing. But in this case, let's say you are given 4. You are given 4. There is no trig identity that governs this, saying cos square y plus sin square y is equals to what? 4. There is no trig identity that governs this. So this is where the idea of parameterization comes. We now say that generally, for equation of a line, for equation of a circle given, by equation of a circle, meaning you have x minus h squared plus y minus k squared is equals to what? R squared. So this equation of a circle, you can write it as x squared. We are using it in this form as x squared plus y squared is equals to what? R squared. So meaning this is our center of circle. So from here, we are actually interested in the radius. R is the radius. Take note, R is the radius. So now, given this circle from the question as x squared plus y squared equals to 1, what it implies is that in this case, you can write this as x squared plus y squared equals to what? 1 squared, saying that R is equals to 1. R equals to 1. Similarly, what if in some question you will be given the radius? So let's say in this case now, let's say another similar question like this. You are given the radius as 4. Okay, you are giving the radius as 2. You are giving the radius as 2. Or you are not even giving radius. You just saw in that question as you are just saying, let's say in that question, you are saying something of this x squared plus y squared equals to 4. Now your radius will be what? Related to what we've explained. Meaning you won't be told that your radius is, you won't be told the value of the radius, but by the time you relate it to what we've explained now, you can write this as what? X squared plus y squared is equals to what? 2 squared. So in this case, r equals to what? 2. R equals to 2. So some question might be straightforward, saying that you are giving this equation and you're also giving the value of the radius. But if you are not giving, you should understand what it is. You should know what it means. Let's say this place is 9. Let's say it is 9, meaning you have what? 3 squared. That is, r is equals to what? 3. So the whole idea of this is what? Parameterization. Now, generally, for circuit, to get the function of x, it is given as r cos t, and for y, it is given as r sin t. So you can interchange it. Your own x might be r sin t, your own y might be r cos t. It's still the same thing because they are actually following cos square y plus sin square y equals to 1. So let's go with this. We're going with this. We are saying that generally the parameterization for a circuit is s equals to r cos t, r equals to r sin t, y equals to r sin t. So make me any question on that green step, I need to implement this parameterization formula of x function and y function, meaning I must know my what? Radius. So from this given question, my radius is what? 1. My radius is what? 1. That is, x function becomes what? X function becomes 1 multiplied by cos t, meaning x equals to cos t. Call this equation 1. And y function becomes 1 multiplied by sin t, meaning y is equals to sin t. Call this equation 2. So you already know the function of x and the function of y. To get the x and the y, just like the way we've been doing, just differentiate x and differentiate y with respect to t. So if x is equals to cos t, the x over the t becomes what? Negative sin t plus multiply, meaning the x is equals to negative sin t dt. Similarly, if y is equals to what? Sin t, that is, dy over the x is equals to what? Cos t multiply, meaning dy is equals to cos t dt. So meaning that performing line integral for this question, I didn't know the value of p to be x, I know the value of the x to be sin t dt, I know the value of q to be what? Y, I know the value of the y to be what? Negative, I know the value of y to be cos t dt. So you are just going to what? Substitute. Doing substitution, using line integral, doing substitution. Okay, now before your substitution, your limit is, just take note for circuit, your limit is always starting from 0 and it is ending with 2 pi. Let's relate this to circuit geometrically. Let's say this is your circuit. Of course, this is the center of your circuit, and your circuit, to cover this circuit, let's say you have this, let's say this is the starting point. To cover this circuit, you are going to move round. You moving round, you are covering what? 360, you are covering 360 degree, and in radian, 360 degree can be expressed as what? 2 pi. We said, let's say this is the starting point of your circuit. So this is the radius. Now this radius, you are covering, you want to cover round this circuit, right? Meaning from this starting point back to where you started. So this starting point is 0, then back to that starting point, meaning you cover 360 degree. Converting 360 degree to radian, you have a 2 pi. So generally, for a circuit, the limit is always constant. Your lower limit is 0, and your upper limit is what? 2 pi. Meaning I have integral 0, 2 pi, substitute your p, use substituting, meaning you have integral of your limit 0 to 2 pi. What's your p? Your p is what? X. Meaning x dot, what's your dy? Your dx rather, negative sin t dt, right? plus what's your q? Your q is y multiplied by what's your dy? Your dy is what? Cos t dt. Now from here you already know what function of x and y. Substitute x is cos t, meaning that you have cos t multiplied by negative sin t dt plus what's your y? Your y is what? Sin t multiplied by cos t dt. Then from here I'm having negative sin t cos t plus sin t cos t dt. I'm having a dt here. So from here, this plus this is what? This plus this is what? 0. This plus this is 0. Meaning I'm having, at the end, I'm having integral 0 to pi 0, which is equals to what? 0. Because there's no way we can integrate this and substitute our limit. We still get what? 0. So for this question, we've implemented line integral, we got 0. Me implementing double integral, if I get 0, it means this question verifies Green's theorem. If I'm not getting 0, it means this question does not verify Green's theorem. By formula, you have your double integrals, integral all into bracket dq over dx minus dp over dy multiplied by what? dA. Multiplied by dA. Meaning that in this case, you need your limit. You need your, okay, this is r, right? Now, what this means is that let's get the partial derivative of q with respect to x and the partial derivative of p with respect to y. If p is equals to x and q is equals to what? Y. Partial derivative of p with respect to y, 0. Partial derivative of q with respect to x, 0, right? Therefore, you have integral r 0 minus 0 dA, meaning double integral r 0 dA. So, and we know that this dA, in some, from here up to this level, by the time you evaluate, you have 0, meaning 0 multiply this, 0 will multiply this, right? So what this means is that Green's theorem is verified. Green's theorem is verified. Why is Green's theorem verified? It is verified because when we use line integral, we got 0. When we use double integral, we got 0. So state your condition. You say that your Green's theorem is verified. It is verified, meaning that Green's theorem is verified. Green's theorem is verified. Why is Green's theorem verified? It is verified because when we use line integral, we got 0, and when we use double integral, we got 0. But in some cases, we got 0 here just because in this case, our partial derivative of p with respect to y is 0, and partial derivative of q with respect to s is 0, meaning 0 minus 0 is still giving us 0. Automatically, this integral function becomes what? 0. That was why we couldn't integrate, right? Now, let's say in this place, we got 2. Let's say our value here is 2. Expected, this dA, I'm going to integrate 2 with respect to x, and I'm going to integrate 2 with respect to what? Y. But how it works here is that this dA means the area of this circle. And what's the area of circle? The area of circle is what? Pi r square. Pi r square. So you are going to substitute pi r square, and you are going to integrate 2 pi r square. Integrate 2 pi r square. But we are going to solve, possibly we'll solve similar question like that. Just know that this is how it works for a circle. Meaning, implement your formula for your parametrization. Alright, this comes to the end of what Green's theorem. There are also advanced questions on Green's theorem, but we'll be stopping here. This comes to the end of what Green's theorem. So our next theorem will be Stokes' theorem and Gauss' theorem. Our next theorem is going to be what? Stokes' theorem and Gauss' theorem. We will see how Stokes' theorem works, and we are going to see how Gauss' theorem works. Alright, see you in the next video. If you find this video helpful, do share your thoughts in the comment section. Never stop learning. For those who stop learning, stop living. Bye bye.